Okay, here we go. Yep. Calculus of logarithmic functions. Here's an example. Yesterday, you found that the derivative of e to the x was e to the x. Today, suppose you do not have e to the x, but rather a different number to the x power, so b to the x. The derivative is b to the x times the natural logarithm of b. I love you too. All right. The derivative of natural log of x. Nope. Is 1 over x. Say you don't have say you don't have natural log. Say we have log base b. You're gonna have 1 over x times the natural log of b in the denominator. Then you need to write smaller. I try to prepare you by writing on the left-hand side. Take out your various calculus notes worksheet. Everybody in their folder, you should have your various calculus notes worksheet. Take it out. Find it. The one that says various calculus notes. Okay. Right here. I want you guys to know, okay, I'll get you one. I want you guys to know that all the derivatives that we just wrote down are over on the left-hand side here. For your next test, just to warn you, that entire list that says derivatives, you're going to have to know all of those for the test, okay? Yep. All right. Let's apply our learning. It's also nice on the various calculus notes sheet that there's also a space at the bottom. Spencer, can I see yours? There's a space at the bottom that says laws of logarithms and basic properties of logarithms. We're going to refer to those shortly. That is not your bell. All right. We want to find the derivative. Natural log of 1 over x squared. Natural log of u and 1 over x squared. I need to find this derivative. Yes, I will show you in a second. Okay? The derivative of natural log of u is 1 over u, because the variable is u. This is x to the negative 2. What is the derivative of x to the negative 2? Good. So what I'm going to do now is I'm going to multiply these together. 1 over x to the negative 2 times negative 2 over x to the third. What can I do with that x to the negative 2? So I therefore have negative 2x squared over x to the third. I'm going to take these two. The chain rule says I have to multiply those two together. I put x to the negative 2 in for u. Now, this reduces to negative 2 over x, which is your derivative. Okay there? Sure. Right here? I took the x and negative 2, I moved it up into the numerator because it's negative. Yes. Okay. B. Now we have log base 4. I'm going to try to get to Taylor's point here, and then we'll break for lunch. No, her point about the log base 4, log base e. For example, if I write log base 4, don't write this down, log base 4 of 64 is equal to 3, what does that mean? Right. Now, we learned a few properties last year that exponential functions and logarithms were inverses of each other. So when you did that to both sides, you raised each as an exponent. These canceled. I got 64 was equal to 4 to the third. Is that correct? Yes. We also learned that you could take the log base 4 of both sides, and what would happen is these are now inverse, and you get our original statement, log base 4 of 64 is equal to 3. So that's a basic little kind of nugget from last year. Go fill your tummies. Come back in a better mood. I'm ready, kids. We got log base 4 of e to the 2x, okay? And we want f prime of x. And so I divide this up, log base 4 of u and e to the 2x. By the way, you'll have a full work day tomorrow on assignment. So, okay. What I need to do now is I need to take the derivative of each. Looking at your rules above, do you know what the derivative of log base 4 is? Very good. Derivative of e to the 2x. Multiply those, and we'll have a 2e to the 2x on top. Yeah, I did. Yep. We have to get to a point where we can see the chain rule. So we've got 2e to the 2x over e to the 2x natural log of 4. So what happens? I'll let you guys guess if that's an h or an ln. I won't say for sure, but you can make your own guess. Okay, let's try C. Because the u is in the denominator. Because got like somewhere between 1 to 3% chance of surviving next year. Gosh. Oh. F of x equal natural log of x divided by e to the x. What? I use the quotient rule. What's the derivative of the top? Times the bottom minus the derivative of the bottom times the top all over the bottom squared. What is e to the x quantity squared? E to the 2x. There's an e to x in the numerator and one in the denominator, correct? Take it out. Now, I have a complex fraction. You cannot leave a complex fraction. You must simplify it. And I'm going to multiply by the reciprocal. Questions on that example? Okay, we're going to add another problem into here. Okay, so yep, we're going to, so we haven't talked about one like this yet. Instead of e to the x, I have 4 to a power, and I have 6 to a power. So I don't have to use the product rule here because it's not multiplication, it's just addition. So just take derivatives of both and then combine them. Yes. Yep, 4 to the e to the x. So 4 to the u, what's the inside? What's the derivative of 4 to the u? If you look at your rules up above, this one right here, b to the x, derivative of b to the x is b to the x times the natural log of b. It's the same thing as e to the x. E to the x, the derivative of e to the x is e to the x times the natural log of e. What's the natural log of e? 1. So that's why it goes away for e to the x. But when you have a base other than e, the derivative is itself just multiplied by the natural log of the base. Derivative of e to the x, e to the x. So if we multiply these together, I get 4e to the x times the natural log of 4 times e to the x. Plus, let's take the derivative of the next one. The inside function is 2x plus 1. What's the outside function? It's the derivative of 6 to the u. What's the derivative of 2x plus 1? So we get 6 to the 2x plus 1 times the natural log of 6 times 2. No, that would be completely illegal. Yep, totally Totally voodoo math. You can't take the 2 times the 6 and get 12. Well, uh, order of operations. Order of operations says you must evaluate the exponents before you multiply anything else. So you can't take 2 times the 6 because the exponent has not been simplified yet. What here? Oh, I'm not adding anything else. No. No. Years ago they came up with this wonderful invention. It's called scratch paper, and you're allowed to attach it to anything that you aren't able to copy down on notes they give you. Chain rule again. What's the derivative of u to the 1/2? What's the derivative of that? Chain rule again. What's the derivative of natural log? 1 over u and 2. So 2 over 2x minus 1. So now we're going to multiply these together. What happens to the 1/2 and the 2? Those will cancel. Yep, just a 1 on top. And you end up with the square root of u. The square root of what is u? Natural log of 2x plus 1. Times 2x minus 1. That's your answer. E. What to do? Any thoughts? Quotient rule. So for you to do the quotient rule, the derivative of the top. Yes, quotient rule. 5 over x would be the derivative of the top. Minus, what's the derivative of the bottom? Negative 2 over x. Times 5 natural log x plus 3 all over the bottom squared. 4 minus 2 natural log of x. Oh, that's not my answer. It's correct in value, very good, but it is not simplified. You guys are the ones that love algebra so much. So. If you notice, they already have common denominators, don't they? So I'm going to multiply through. This could be over x. What's 5 times 4? 20 minus 10 natural log of x plus 10 natural log of x plus 6 all over x all over 4 minus 2 natural log of x quantity squared over 1. All right, what cancels? These go away. What do you have in the numerator? 26. With all due respect, my speed is 100% appropriate as long as everybody zips their mouth. So, what is in the denominator when you multiply by the reciprocal? X times 4 minus 2 natural log of x quantity squared. That's the derivative. Okay, last example. We want to use logarithmic differentiation. So I taught you a method called implicit differentiation. Remember that? We're going to incorporate implicit and logarithmic differentiation together. It's a way to make things a little bit, it's just a different method that's useful as you go on in mathematics. So we'll do another example tomorrow. You'll have the whole time to work on class other than that one example just to refresh your brains. But here's how it goes. First I write it as y equals the root of x times e to the x times 2x plus 1 to the 20th. And what I do is I take the natural log of both sides. Now, this may look bad, but if you remember at the very beginning, we had 3 terms there that would be multiplied together. Taking the derivative would require the use of the product rule twice. It gets a little bit messy. And as soon as you say, well, I don't care if I have to do the product rule twice, well, let's put on 2 more terms there so you have to do the product rule, say 3 or 4 times, okay? All of a sudden it becomes much more challenging. So we could make this significantly more difficult. So just watch a step that I do here. Do you remember what we could do with logarithms of products? If you look at your various calculus note sheet, at the bottom it says this, that log base a of a times b is equal to log base a of a plus log base a of b. So you can separate the product of 2 things inside a logarithm to addition. So that's going to be to our benefit. So we have natural log of y is equal to natural log of the root of x plus the natural log of e to the x plus the natural log of 2x plus 1 to the 20th. That's a good question. Why can't you square both sides? Because you create an extra solution, right? And so you have to be, we do square things on both sides all the time. It's just we have to be careful when we do so. And when you take the natural log of both sides, we do need to be careful we do so just in this. The only thing you can't take the natural log of is negative numbers. So as long as we make sure that there wouldn't be any natural log of a negative number, we're okay. We're not going to watch it right now, but later on during the course of the year we will. All right. Now, do you remember what you could do with exponents? Move them out front. So this is x to the 1/2, so I can move that out as well. So I'm going to get natural log of y is equal to 1/2 times the natural log of x plus natural log base e. That just goes away, right? These are inverse operations. Natural log and e to the x are inverse operations. They go away. I'm left with x plus 20 times the natural log of 2x plus 1. So now, am I required to use the product rule at all? No. So let's just take the derivative. Take the derivative of both sides. Here's where it's just a little tricky. What's the derivative of natural log of y? 1 over y times y prime, right? Using implicit differentiation, we have to attach a y prime every time we take the derivative with a y. So we have y prime over y is equal to, what is the derivative of 1/2 natural log of x? 1 over 2x. What is the derivative of x? 1. See, isn't this much simpler to take the derivative of? Plus, now this does require the use of the chain rule, so I'll quick set that up. 20 natural log of u. I have 2x plus 1. Derivative of 20 natural log of u. 20 over u, derivative of 2x plus 1. Multiply, together I get 40 over u, or 40 over 2x plus 1. No, we're basically done. We just have to take care of this y in the denominator. So I'll multiply both sides by y. And then I don't really like having the y there because when we have a derivative, it's much nicer to just have it in terms of x. A for the day, what is y equal to? Square root of x times e to the x times, yep. See, y is equal to, right here, square root of x times e to the x times 2x plus 1 to the 20th. So therefore, we will insert that, and that will be our answer. Y prime is equal to square root of x times e to the x times 2x plus 1 to the 20th times then that remaining quantity, 1 over 2x plus 1 plus 40 over 2x plus 1. So, isn't it interesting that the derivative of this includes the original function? That's often what happens when you use logarithmic differentiation, and it's really nice. It makes things easier moving forward. Okay. So your assignment, you're going to have a full work day tomorrow, so make sure that work days are much better when you have work done ahead of time, and then you can get your questions taken care of during your work day. If you're starting on question 1 from 7.2 tomorrow, then that's fine, but don't be surprised if you get a little bit behind then. So if you come with your questions ready to go, life should be better. 1 through 17 odd, 21 through 23. I gave you guys the sheet, okay, because you don't have a book. So I gave you the printed off pages, okay? Have a great day. Tomorrow, we're going to have a silent day where we don't yell back and forth at each other and complain at our teacher for... Yep. Okay. We could go back to a seating arrangement where we separate one another, so... Yep, and then press stop. No, that's the